Hey, I'm Brandon Cross from Hoyack, and for today's Whiteboard Wednesday, I'm going to cover an interesting topic that I think is really relevant to today. So, I'm going to talk about the way that we build out a, a modern development kind of environment. Okay, so I think there's a lot of people that need to know kind of how this works, and there's a lot of movement happening in the field of like being able to strap an app together quickly, build it up, vibe coding it in some cases, or there's organizations focusing on context engineering. There's professional software development groups that are focusing on um, the usage of the tools in efficient ways to help to increase the ability for them to do a lift. And so I want to kind of cover this because I think there's some needs to understand kind of how to set these things up correctly. And so at the fundamental level, it seems like there's a few different platforms that everybody is using. At the the most one of the most common platforms people use is the Mac, and another common platform people use is going to be Windows, and then another common platform that people might use less commonly but still often used is going to be Linux. Okay, and so these are the three kind of most common. Well, I don't know what else. Like, there's mobile, I guess you could say. There's like fringe that are doing like Android, which is technically kind of under Linux. And then there's maybe people that are focusing, that are maybe want to do something on the iPhone only or some other kind of device. I'm not going to get into that. But up here, the ones I care about are the Linux, Windows, and Macs. Okay, so in on the Mac, now all of these are going to have a few common things that they're gonna need. Except now the Mac it comes with basically the SSH environment. Okay, so one of the first things that we need to do is we need to typically use a little bit of the shell. We don't have to, definitely don't have to. We can skip past that, but it's a good thing to know how to use. So, but in Windows, one of the problems with Windows is that it doesn't have all of the things that a lot of the Linux environments can call in, and conversely also the Mac environments too. And so But it can do that when you install WSL, which I like to do WSL2. So WSL2 is the next layer that you have to install. So when you set up Windows, the very first thing you want to probably do, in my opinion, and this is my opinion, is you want to enable WSL, Windows Subsystem for Linux. And that's going to give you like a full-blown like Ubuntu environment. Okay, so now these two are essentially the same. Okay, there's a little bit of a difference. All right, one of the big differences is that you may have a GPU over here. Okay, and you want Windows to be, you want the WSL2 to talk to your GPU. All right, and so I'm going to kind of talk through a little bit of this, so you can kind of understand some of the complexities. But if we just look at this, then this is one of the big differences in how now this might have usually the Mac isn't. I mean, most Macs aren't going to ship with like the certain ones ship with a kind of GPU. So there is GPU you can install on a Mac, but either way, you may or may not have GPU, and these devices are connected to the physical hardware. But now in Windows, you have this extra layer in between here, and so you have to make sure that this is talking to to this system, so that you can run commands from this system through to the GPU. And so now WSL2 has that kind of integration built in, okay? But one of the problems is that, okay, you basically need your, if you're running like an NVIDIA GPU here, you're going to need like a specific, you're going to install the driver, and then you're going to install the CUDA drive, the CUDA stuff, and the version of CUDA that you're running might have mismatches across this system, and it might create some issues. So setting up like the thing to where you get the right versions that are lining up from Windows, what's installed and running here, then WSL, what can be installed and running there, and then further down the line, in your stack and your runtime, what it needs, because it might need a specific version of like the CUDA tools, and your version of CUDA tools might be too old or it might be too new. And so you may have to make adjustments there, but you may have to make the adjustments on kind of sometimes on both sides to get things in alignment. So a little bit of complexity there. With Linux on bare metal, you don't have that problem really as much. And you can install the NVIDIA drivers pretty easily, install the CUDA runtime, install the CUDA tools, and it's a little easier to get that running, but then you don't have the advantage of running Windows and having your whole Windows environment there. But you can still run like Ubuntu with GNOME or whatever and have a really nice environment. It's just a lot of people's good GPUs are on their like Windows rigs and not on native Linux. Now I'll run a lot of native Linux with good GPUs, with so that I don't have this extra layer here. But things get really interesting because there's another layer that we oftentimes put in place, and that's going to be Docker. And so we can install Docker on any of these systems, okay? And now Docker isn't necessarily always ever important or required. We don't have to have it. In fact, a lot of times, like if I'm running Python stuff, I'll run I'll end up running Anaconda, and and that's creating like virtual environments. And the same thing over here, I'll be running Conda, and then kind of over here as well. So I might be doing development with Anaconda, and then rolling up to Docker. But all of these systems can run Docker, can run Conda environments. Not that you need Anaconda, it's just one that I use instead of VENV, specifically with Python. Now, of course, you also have to run, a lot of times you have to run Node on these things, as well, especially if you're doing like an environment, like a dev environment. So, which is fine because you can install Node all over the place. But, one of the problems that we run into is that, if you're running, okay, so here, let's just focus on like up here at the Mac. The Mac is going to have like, it's got like, let's say, a Wi-Fi connection, okay? And that's got like some IP address on a local network, 192.168, 1.100, okay? But, and then it's got like a local host as well, local host, which is going to be 127.0.0.1, of course. And so in this situation here, your node server is easily being served on, whatever, port you're starting some node app on, and you're connecting all interfaces just fine there. And so, when you run your code, and in many cases, be it out of even a Docker container or directly locally, then, you can hit that local environment across it. So it's an easier way of being able to, when you have the straight environment you need, which is essentially a Linux environment, then, it's going to be a lot easier for you to run these programs, but for you to execute your code and do testing and all this jazz. However, in Linux, it's the exact same situation, okay? It's the exact same situation. You have whatever your Ethernet adapter is. You've got like, ETH0 and, of course, localhost. And so these things they're bound right there. It's really easy to get ports off of them and dangle ports. And then Docker is kind of already, it's a little bit easier to communicate with Docker right there. But one of the challenges you get into is in Windows, where like you may be running Node over here and maybe you're running Docker over here. Maybe Docker is exposing something at 127.0.0.1, and that's able to talk to, maybe localhost here, and which is the 127.0.0.1. But then you need to you open like a web browser up here in Windows, and then you're hitting whatever port you're serving, and you're trying to open local host 3000 on in there, but you're talking to this local host, okay? You're not talking to this local host because you have this extra layer. So there's this, so you have to make sure that this can be served all the way to that. And then to make things more complicated, you can also launch Chrome out of WSL itself as a Linux compiled application that then pops up in your Windows GUI and looks like normal Firefox or whatever, or Chromium or whatever. It's inside of Linux. So you can launch Linux applications that show up in your Windows GUI. You can launch Windows applications that show up in your Windows GUI. And these applications might be talking to two different network subsystems, okay? Right? And then to make matters even more complicated, you can install Docker, okay, on Windows, all right, have it talking to that, and then have stuff running over here that can't talk to this, because you have to have the Docker has to be integrated with WSL and Windows. So when you really want to get into complicated stuff, you need GPU access off of Docker through WSL, crossing back through the Windows subsystem. And to get that whole thing to work it requires all the pieces to be aligned. Okay, so that's one reason why like Mac is a little easier, Linux is a little easier. Like a lot of people like their Macs because it doesn't have all this extra stuff that you're dealing with, and then all this extra stuff didn't always work. It only worked in the last few years. So 5-6 years ago, you couldn't even do this. You could try. There was Windows subsystem for Linux existed, but having Docker pass through, having GPU pass through in any of these layers did not. And so now the WSL2 is where the GPU pass through started really working. But you still have to jack around a lot with what's running locally where, so that you can make sure that things get exposed. Because then what's even more confusing is that inside of Docker there's another local host, and so you have literally the local host that's here, but then you also have the local host that's here, and then you have the local host that's here. So inside of Windows, just with a Docker, just a simple Windows 11 with WSL2, Ubuntu subsystem with Docker, we have 3 different local hosts. And so there's actually a way in Docker, I don't have the command off the top of my head, but there's a way that you can specify here, instead of calling localhost, you call this Docker URL that then it knows to pass it through to whatever. Because you might not even expose any ports off of that, off that Docker container might be something that needs to talk amongst itself to itself. There may be other Docker containers side by side there that need to talk to each other in their own little network, and maybe there's one port or maybe there's no ports, right? So there's a whole bunch of different like configs that you might be doing there, okay? But then, okay, so that's cool. But now, in terms of like a setup of an environment, what else are we running here? Well, one of the other big things that we're running is we're running VS Code. And so what I like to do is I like to install VS Code. And so we can call VS Code by running by being in a directory and running the command code space dot. Okay, and so if we run code space dot in whatever directory we're in, if we have VS Code installed, it's going to fire up VS Code. And in Windows, when we do this off WSL2, we basically do it off the command prompt here. We run code dot, and it will fire up VS Code that's inside of Linux with the directory structure of whatever folder you're in Linux. So if you go in and you open up a terminal, okay, if you're in Windows and you open up a terminal and you go to your WSL terminal environment, which you can usually drop down from the little top of the shell window, and there's like a Ubuntu will be there, or Linux will be there, or you type a command in, I think it's WSL or something, and it starts it up. So you go in there, and then from there you like do mkdir, like make a directory, let's say work, okay, right? And then you might like pull a repo, right? There might be like some GitHub repo that you want to like pull, okay? Like I'll give you for example. If you pull the repo for N8N, okay? It's a very simple, common repo. It's public, open source repo, okay? So let's say you pull the N8N repo, okay? And then let's say you're on Windows doing this, okay? Now, you're inside the Linux subsystem. It's like an Ubuntu environment. You made a directory called work, okay? So you have like work / and then like this, and then you did like a git clone, and then you got the URL to clone the directory from N8N's website, and you pulled down N8N, okay? So, all right, so now git pulls down N8N. Now you have to make sure that the git command might have to be installed. There might be like an install command you have to run in WSL to actually be, have access to the git command, but you pull that down, okay? And then now you N8N. Now you basically you change directory there. You run code space dot, and then boom. Now you're in VS Code. Okay, and so now you're in VS Code and you're inside the N8N directory. Okay, and so at this point in time, what you want to do is you want to have node installed. And you want to. Then what you want to do is you want to go into VS Code, and now this could be in your Linux, this could be in your Windows, this could be on your Mac. It doesn't matter at this point. You've got these prerequisites met. Okay, you have Docker installed, you have Docker Desktop. You went to the website for Docker, you downloaded Docker Desktop, and you installed it. And in Windows, you did that, and you made sure that WSL support is enabled in the Docker settings, and then you also go into the network settings in Docker, little preferences under the little gear, and you set to enable local networking. So that way it can talk Docker can talk to localhost all the way back at localhost, if you want to do it that way. Okay, and then and you have all of this jazz here. Now you're sitting here on N8N, and so then at this point in time, you're like, cool, well, let's get the N8N repo running. Okay, so there's a couple of ways that you can do this. Okay, now I'll tell you one way is you could just you could open a terminal up, okay, inside of VS Code, okay, a terminal, and you could type in Claude. Okay, now if you have that installed because you have Node installed and because you installed Claude, which you went to Anthropic's website and looked at the install string and installed the Claude thing there, boom, then you're going to get like Claude starts up and, you authenticate with it for one time or whatever. You tell it, okay, yeah, you can hit this directory that I'm in. Then you can say, Claude, make the project that I have open here for this N8N repo start up in a Docker container that I can access. And so if you tell Claude to do that, then Claude is going to go and it's going to go and look at this thing, and it's going to go and look at your environment, and then it's going to install it and compile it and pull the requirements in and containerize it and run Docker Compose and turn up the container, and it's going to be like, here you go, you can access it here. And so that's like a great example of something you can do where you can set this whole environment up like this, where you install Windows subsystem, you install Docker, you get all of those pieces cross-connected, you install Node inside of WSL2, you install Claude, you go in and then you start up VS Code. As you create a directory, you pull in a repo, you start VS Code, then open a terminal up in that, which you could do it without VS Code. You could just literally just be in that directory and just type Claude, and then you don't have to be in VS Code. Okay, like this is not a prerequisite. Typing the word Claude after you install it from Anthropic, if you're inside of this directory in Linux, in any Linux environment here, it's going to work. It won't work in Windows, MS-DOS, or PowerShell. It will work in WSL2 on Windows, which is why you have to have all this stuff. And so, because you go to get this to work in Windows, to get Docker to work, you have to go to Docker's website, download Docker for Windows, enable the WSL2 option, and then at that point, when you've started Docker in Windows, then you can go into your WSL terminal and you can type in, Docker, and it'll run the Docker command. And if you don't have Docker started in Windows, then a command won't be found. It's like it doesn't exist. So, okay, so you set all this stuff up, and then, and now there's another way you could do this, okay? Instead of using Claude for this, okay, what you could do is you could install in VS Code the Cline extension, okay? And then what you could do is, now this is where things get a little wild, is you could install in Linux or Windows locally, or on Mac, you can install Llama. Okay, so I'm going to put Ollama. And so you get Ollama running, and you pull a model in, let's say, some Llama model, Llama 3.2 or whatever, whatever your hardware can handle. And then you hook Cline up to that, okay? And now, and by the way, you could be running Llama inside of Docker as well if you really have your stuff together. If you want to do some really cool tight config, then you get the Docker GPU stuff flowing through. You get Ollama installed inside of Docker, exposed as a Docker container, instead of running Llama locally. In Windows, you might just want to download Llama for Windows, install it, and then expose it on, all interfaces, and then have your system over here, your VS, talking to inside of WSL2, talking back to your Windows network interface that's got, Ollama running off of it. Another thing you could do is you could install Ollama inside of WSL2, completely not install it in Windows, install it directly inside of WSL2. It'll start up on the WSL2 local host, and then you're not talking to it from inside of Windows really. What you're doing is then you're launching VS Code with code dot inside of your folder inside of Linux that you created, and then that VS Code instance is going to have context to talk to the WSL localhost, which is going to be running the Ollama on localhost. So then you can set Cline up to talk to it. And this is also important, really important, because when you get N8N's container to start up, You can drag and drop the AI agent for N8N onto the screen, wire it up to Ollama, point Ollama at your local host Ollama, and be able to run an AI agent locally, okay? And so but you could set that up, then you could tell Klein, hey, Klein, install N8N. So what I'm saying here is that you could use Ollama and Klein to install a system on your system without you knowing how to do it, without you talking to an external AI. You could also use Claude if you have like an Anthropic subscription, Claude Plus or whatever. You can access Claude, and then you can have it do that as well from a terminal only or from inside VS Code in a terminal. Okay, I like to do it in VS Code because it's gives you extra features. So either way, that's the way. And now N8N could be running locally on your Linux environment inside a container, or inside your WSL container, or on Linux, on Mac, in a container, or not in a container. It could just be running, it could be running outside of a container, and it's just exposing the port. Okay, but either way, you could run it. You can run that, and then if you have it running like inside a container, and then it can talk back to the local host Ollama, then your N8N can communicate with a local AI that it can then send queries to, and the AI agent feature will be able to use a 100% local environment, local GPU, all the way through with Dockerized containers, with N8N, with Ollama, both Dockerized right there. And then if you want to get really fancy, you drop in Web UI, Open Web UI, okay, which you could run a Docker container for that, okay, and then Web UI can talk back to your local Ollama, can also talk to other models, but yeah, you can have like an entire environment that is a full stack, fully integrated AI system, okay, that contains the Web UI. Okay, now Web UI, I've covered this before. This is essentially ChatGPT for free. Now you can wire up. Now then you can have Ollama in here, and then Ollama's running, and now you can have that running a model, like for example the new OpenAI model, the new forget what it is, GPT SSO or SOO or something. It's a new one, just came out like 2 days ago. You can have that wired up, right? So now Web UI is talking to Ollama. Ollama's has like a model that it's talking to, and then Klein is sitting in VS Code. Well, you're running N8N, okay, as a container, and then it's also talking to Ollama, okay, right? And then you've got outside of that, you've got your browser, and you've got your browser, and you've got your VS Code, your IDE, and and these are talking to, that's talking to Web UI, that's talking to N8N, and then you've got Klein over here outside of VS Code, and Klein's talking to Ollama, and then it's talking to whatever code that you want to write, and so now you're able to generate code. You're able to generate, instructions and prompts and anything you want. You could, in Web UI, you could also install another container, and all of this is like Dockerized, okay, right? It's all Dockerized, and there's other Docker containers that you might want to run. There's a whole slew of different Docker containers that kind of apply to this. But this is a pretty fully integrated environment where you're talking, you can generate all the text stuff you want. Yeah, there's, this Open Web UI will do image generation. You have to hook up Stable Diffusion to it. So you'd have to install like Automatic, I think, as another container, and then download the Stable Diffusion model, and then, or Flux, I guess, or whatever. And then you could have that wired up. And then, your OLAMA is handling the local models that you want to run. And then your N8N is handling like low code, no code processes. It's kind of a back end automation system. And then Klein can build your front ends, integrating with N8N. It can build standalone middleware backends. It can configure the system to do things and help you to execute stuff. And that's all a closed ecosystem. Now, a better ecosystem is to use like the ChatGPT and Claude's web UIs directly with their best of breed products. Using Claude code instead of Klein. Klein can also use Claude and various things like that. So, that's kind of interesting. A better best of breed environment there. N8N, it can run locally or it can run in the cloud. The N8N cloud is pretty good as well. A lot of people are using N8N cloud. The webhooks are already exposed. You don't have to do something like fire up some webhook off, and then use ngrok, which you can use. You can use ngrok, for example, to sit there and expose a webhook to, the open web. And so now your N8N system, you can have things that are, able to hit those hooks, and then these other systems that are out on the open web that then can sit there and trigger, your application. Another one you could have is a Postgres container, because or a Supabase container. You can run like Supabase locally, right? So your N8N might want to talk to like local Postgres, local Supabase, because you've got something running there. You might have ngrok exposing stuff, or there's a Cloudflare Zero Trust tunnel you could set up real easily as well, pivoting right off of any of these environments directly. So that's kind of a technical walkthrough of how to build, your own environment, kind of a dev environment for doing any kind of software development, especially utilizing the latest and greatest AI-driven things, because this is like a secure stack. This can this can be set up to talk to the best of breed models, or it can be set up to only talk to its own self. So if you want to build something that's like HIPAA compliant, that's like a higher security type thing that has, that the AI needs to be able to be in the environment, but you can't send the data out of the environment, then you want to build something like this, because this is the private AI ecosystem stuff. So hopefully that kind of helps to answer questions about like how this stuff works and how everything is kind of wired together, and these different environments, and why you might want to use one environment over the other. I use a lot of the Windows environment in the dev stuff. I don't find it to be very limiting, but I do like the Docker. It's a little bit easier. The Mac stuff is pretty easy as well. That's probably why it's one of the most popular. But yeah, getting the Docker containers all lined up is like really important. Getting your GPU accessible through that pipeline can be important. Running, knowing how to install OLAMA and pulling a model down, having the GPU to back that is like, that's why that Windows GPU, NVIDIA type platform is very common, because otherwise you've got to install bare metal Linux on like some really good rig. And, you might want to use that rig for other things, especially if it's a dev rig. Then, having the WSL2 with the VS Code, running Docker through that, gives you like the same power as running Claude on Mac or Claude on Linux natively. So yeah, and then Dockerizing, I think, makes it really easy to run these kind of services without having to like expose all this different stuff. Without, it's just one thing. It's got everything exposed inside of it. Otherwise, you have all this other stuff that starts to get shot out there, and you're spooling up this port and that port in this service and this service and that port in this service. You don't want to do that. You want to have everything just running inside of containerized services, and then then that way it makes it easier to deploy those later into another system too, because a container is a container. So, all right, so I'm Brandon from Hoyack, and yeah, this is a setup that I use every day.